The last step to completing your spell checker is to implement the unload function, which is responsible for freeing up any memory that you've allocated in the process of running your spell checker. What does this mean? Well, remember that anytime you dynamically allocate memory using malloc, it's also your responsibility to call free on that memory to free up that memory and give it back to the computer. So what is your unload function going to do? Well, your unload function is going to call free on any memory that you've allocated using malloc and return true if it's able to do so successfully. How are you going to do that? Well, remember again that your hash table is really just an array of individual linked lists. Each of those linked lists contains nodes that you have allocated memory for, likely using malloc. So you'll need to free each one of those nodes. So you might imagine iterating over your hash table, going over each of those individual linked lists and calling free on all of the nodes inside of those linked lists. But how do you free all of the nodes in a linked list? Let's take a look at an example. Here again is a linked list where we have a variable called head, which is going to be a pointer to the first element in the linked list. In this case, a node that has the word bat in it, which has a next pointer that points to book, which has a next pointer that points to banana in this case. And let's imagine how we might free up these nodes that we've allocated using malloc. You might imagine again that we could have a variable called cursor, which is set equal to this node here. It's a pointer to this node bat. If I wanted to free this node, which I originally allocated memory for using malloc, I could use syntax like this: free cursor, to say, take what cursor is pointing to, this node, and go ahead and free up that memory. But if I did that, what you'll notice is now suddenly I've freed up that memory, which means I've also freed up the memory that was allocated for the next pointer, that gave me access to book and banana and all of the remaining elements inside of this linked list. So you'll want to be careful. If you free up some memory before you're done using it, you might lose access to the rest of the nodes in the linked list that you also need to free. So what's the solution here? We probably need some other variable to help us keep track of where we are in this linked list and to make sure that we don't lose track of any nodes. Let's go ahead and try this again. Here, in addition to a variable called cursor, which is currently looking at the very first node inside of this linked list, I'll create another variable called temp, which is going to be equal to cursor. They're both pointing to the same node. In other words, they both contain the address of this first node inside of the linked list. Now what I'd like to do is free this temp pointer, which is pointing to this first node, but I want to make sure that I don't lose track of the rest of the linked list. So what I can first do is say something like cursor equals cursor arrow next, to say go ahead and move the cursor to the next element in the linked list before we free the first element. Now cursor is pointing to the second element in the linked list, so if I run a line of code like free temp, I can free up the bat node without worrying about losing the rest of the linked list. Cursor is still pointing to it. And now I can repeat the same process. Go ahead and set temp to be the same thing that cursor is, have temp point to book as well. Then, to make sure we don't lose the rest of the list, go ahead and move cursor, and then we can free up the space that is allocated to what temp is currently pointing to. Free up that node and repeat the process. Have temp be set to the same thing cursor is set to, move the cursor forward, and then free up temp. And eventually, once you get through this entire process, what you'll find is that cursor is pointing to null. In other words, you've reached the end of the linked list. And at that point, that'll tell you that you've freed up all of the nodes inside of that linked list, and you're done, freeing up all the memory that was originally allocated for those nodes. If you repeat that process for every one of the linked lists that's inside of your hash table, the result will be that you freed up all of the memory that was allocated for your hash table. My name is Brian, and this was Speller.